I did a thing this morning I've done 1,000 times and never once thought about. Pulled a wool sweater off over my head in a dark room, and the whole thing crackled. Little snaps, that faint tearing sound, a spark you can actually see. And then one strand of my hair stood straight up and refused to lie back down. I want to start right there because I think that stupid everyday crackle is hiding the whole of this new course.
It's hiding most of it, honestly. That crackle is the same thing lightning is, only shrunk down until it fits under a jumper. The same force, the same actors, the whole cast. And you picked a good doorway because this course changes the subject on the last one. The last one was about how things move, what makes a thing speed up, or turn, or coast. This one is about what does the pushing in the first place.
And that's the handover I want to be careful about. Last time, a force was an arrow you drew onto a thing. You shoved the cart, gravity pulled the ball, off it went. And the force was always somebody's hand, or a rope, or the ground. Something touching something.
And your crackle touches nothing.
Nothing at all. My hair stood up with nothing anywhere near it. No hand, no rope, no contact.
That missing contact is the puzzle the whole course cracks open. Let me hand you a cleaner version of your sweater, one you can build on a kitchen table. Blow up a party balloon, ruck it briskly on your hair, then press it flat to the wall and let go. Just step back and watch what the balloon decides to do.
It sticks. Everybody's done this. It hangs there, no tape, no glue, holding up its own weight for ages. As a kid, I was dead sure it was suction, the rubber gripping the paint. It's the same family as the winter doorknob, isn't it? You shuffle across a carpet, reach for the metal handle, and a spark jumps the last little gap and bites your fingertip before you've even touched it.
The very same family, and the doorknob spark is that gap finally being crossed all at once, in a rush, instead of quietly. It isn't suction, it's the crackle standing still. Rubbing loaded the balloon up with something. We'll name the something in a minute, and now it holds itself to the wall with a pull that beats its own weight. And here's the half that matters more. Rub two balloons the same way, hang each on a thread, and slowly bring them near each other.
They swing apart. I remember this one. Each balloon leans away from the other, mildly disgusted, hanging on its thread at an angle, holding a clear gap of plain air between them. And neither one will close it. You can even feel it with your hands if you bring the balloons together yourself. This soft, springy resistance in the empty air, pushing back, getting firmer the closer you shove them. Nothing there, and yet it pushes on your hands like a cushion made of nothing.
Nothing crosses that gap your eye can find. No string, no rod, no puff of air. Yet each balloon plainly shoves the other off, hard enough to lean out against gravity and stay there. So sit in how strange that is. Every push you have ever met in your life had a middle, a place where two things touch and one leans on the other. These two shove each other across a gap that has no middle at all.
That's the thing I never noticed until right now. When I shove a door, my hand's on the door. Every push I've ever felt had that meeting place, the spot where the two things press together. These balloons push across a gap with no meeting place anywhere in it.
A hole in the story, right where the touching should be.
A hole right where the touching should be. That's exactly it. And I have no idea what goes in it.
Filling that hole is the work ahead of us, and what fills it turns out to be as real as the balloons, though you'll never see it. But first, what got loaded into the balloon when you rubbed it? Let's name the stuff and learn its rules. It's called charge.
Charge. The word means almost nothing to me, one of those I've said my whole life pointing at nothing in particular. Phone charge, charging bull, who's in charge here? If I could scoop up a spoonful of pure charge, what would I actually be holding?
You can't scoop a spoonful. That's the first thing to get straight. Charge isn't a substance on its own, like water you pour into a cup. It's a property that bits of matter carry, the way they also carry mass. Some pieces of the world have it. And here's the first real rule, the one Franklin handed down. It comes in two opposite kinds. We label them plus and minus, positive and negative.
Two kinds. And I'm guessing the names aren't just two flavors minding their own business. Plus and minus, like they're built to cancel, the way a debt cancels a payment. Which would explain why most everyday things sit there doing nothing chargy at all. A chair, my hand, a cup of tea. They're not empty of the stuff, they're just carrying the two kinds in a dead-even balance, so the whole thing reads as nothing from outside.
They cancel in the arithmetic, yes. But the names really matter in how the two kinds push, which is the whole personality of this force. Here's the rule. Two charges of the same kind push apart. Two of opposite kind pull together. Like shoves away from like, opposite drags toward opposite. That one sentence runs everything that follows.
So that's why my two rubbed balloons fled each other. I gave them both the same kind, so they shove apart. And if I loaded one plus and the other minus, they'd do the reverse, swing together and cling. Same setup, one sign flipped, and repulsion turns into a hug. So one single rule covers both the fleeing and the clinging. I don't need one law for pushing and a separate law for pulling, just the two signs, and whether they match.
Repulsion turns into a hug. And notice what that already hands you, sitting under the balloons, a force that can go two ways. Think back to gravity, the engine of the whole last course. Gravity only ever does one of those two things. It pulls. Every scrap of mass draws every other scrap toward itself, always toward, never once away. There's no anti-gravity anywhere, no lump of mass that shoves.
Right. I've never watched a rock flee another rock. Gravity's a one-way street, everything drawn inward forever. This charge force has both gears. It can pull opposite together, and it can drive like apart.
Two moves, and that second move, the shove, changes everything downstream, because charge can arrange itself. Balance, hold things at arm's length, push back as well as pull in. It's why a scrap of matter can sit there stable and content instead of collapsing into a heap. The shoving holds it open. Gravity, with only its one inward pull, could never do that. But first, I owe you one more rule, and it sounds dull until you see what it forbids. You never make charge, not ever. You cannot create a scrap of it from nothing, or destroy a scrap either.
Wait, but I made some this morning. I rubbed the balloon and it went from doing nothing to sticking on the wall and standing my hair up. That sure looked like I manufactured a whole pile of charge out of a balloon and a bad case of bedhead.
You didn't make it, you moved it. Both the balloon and your hair were already stuffed full of charge before you started. Both kinds, plus and minus, in perfectly matched amounts, so each added up to nothing overall. Rubbing them together did one single thing. It scraped a little of the minus off your hair and carried it onto the balloon. It relocated some. It conjured none.
So the balloon pickpocketed my hair. It walked off with some of my minus, so now it's carrying extra minus, and my hair's short by exactly that much. And that's actually why the hair stands up. It's been left the opposite kind, reaching after the balloon that robbed it, while my individual hairs, all left the same, shove each other apart.
That's the whole crime, and you worked out the aftermath. What your hair loses, the balloon gains, down to the last bit, matched perfectly. Charge is never made and never destroyed, only carried from one place to another. The grand total never budges, and it scales all the way up. A storm cloud is the same robbery, monstrous. Ice and water churn and scrape past each other inside it, stripping charge apart, piling minus at the bottom and plus up top. And when the pile grows big enough, it all leaps back across the gap at once, a spark miles long. That's lightning. Your sweater, writ enormous.
So every time I fight a staticky sock out of the dryer, Clinging to a towel like its life depends on it, I'm watching a tiny robbery. The sock and the towel spent the whole tumble picking each other's pockets, shuffling minus back and forth, and now they can't let go. My laundry's a crime scene. I've been folding stolen goods for years.
And every bit of it books out even. The sock's gain is the towel's loss, penny for penny. Now you said the balloon walks off with charge down to the last bit, and there's a real question hiding in that. Is there a last bit? A smallest amount you could move, or can you shave it as fine as you like, forever?
I'd have assumed you could shave it however fine you wanted. Like water, always a thinner trickle, no flaw to it. But you're asking like there's a flaw. A smallest possible sip of charge.
There's a flaw. Charge comes in grains, tiny identical grains, and you only ever move a whole number of them. 1, 2, 1,000, a billion, but never 1.5, never a sliver of one. The charge on your balloon is some vast whole number of identical little units. It only looks smooth from far off because the grains are so unimaginably small.
So the stuff's secretly made of identical little coins, and I can only move whole coins, never melt one down. That's a strange thing for the world to insist on. It sounds like it's telling me something deep about what matter is underneath.
It is, and it echoes down the next 100 years of physics. A whole world built out of indivisible grains instead of smooth stuff. But it's a thread for far later, so let me tie a knot in it and hang it on the wall. Charge comes in grains. For everything we do tonight, big whole numbers of tiny grains look perfectly smooth, and that's all we need.
Not tied, hang on the wall. So I've got the whole cast now. Two kinds, like shoves like, opposite pulls opposite, it comes in grains, and you can only move it, never make it. What I still don't have is any sense of how hard. When the balloons shove apart, what sets how hard they shove?
2 dials, and I think you can nearly guess both. The first, how much charge is in play. Load a balloon up more, and it shoves harder. Double the charge on the one balloon, and you double the push. Now here's the less obvious part. Load up both balloons, and the two amounts don't add, they multiply. The strength climbs with the one charge times the other.
Hold on, why multiply though? I'd have bet they'd add. Why should loading up the second balloon change anything about how hard the first one pushes?
Because doubling either one, on its own, already doubles the push. Double the charge on the first balloon, and its shove is twice as strong. Twice the push reaching across to the second. Now leave the first balloon alone and double the second instead. Now there's twice as much charge sitting there to feel that shove, so the force doubles all over again. Double either balloon, the force doubles. And the only rule where doubling either amount always doubles the answer is one where the two amounts multiply. A sum could never behave like that. That's what grows with the product means. The one charge times the other.
So double one, double the push, double both, 4 times over. A product, not a sum. And I feel why now instead of just taking your word for it. That's dial 1. And dial 2 has got to be distance.
Distance is dial 2, and farther means weaker. But the way it weakens is the thing to nail down, because it's steeper than your gut expects, and it's the same steepness as something you already know cold. Let me not tell you, let me make you predict. Pull the balloons twice as far apart. Don't work it out, guess. Twice the distance. What happens to the push? Half?
Yeah, my gut says twice as far, half as hard. Even trade, double the distance, cut the push in half, 1 for 1. That's what feels fair. Why the look? That's the look right before you tell me my gut walked into a wall.
Your gut walked into the wall. It's not half. Pull them twice as far apart and the push drops to a quarter. Not a half, a quarter. Pull them 3 times as far and it falls to a ninth. The distance fights you far harder than any even trade. Every time you double the gap, the push doesn't halve. It quarters.
Hold on, let me chew on that. Because a quarter and a ninth aren't random. Twice as far, a quarter, 3 times, a ninth. So, 2, square it to 4, push is 1 over that. 3, square it to 9, 1 over that. The push falls off like 1 over the distance times its own self.
There it is. The square of the distance, doing the damage. 10 times as far, and you're down to 1/100th of the push. Near enough nothing. That steep fall-off carries a name, Coulomb's law, after the man who pinned it down. And there's something buried in it that should stand the hair on your neck up alongside the hair from this morning.
Go on then. What's buried in a fall-off law about balloons?
That steepness, the push fading as the square of the distance, is the very same law gravity obeys, the identical shape. Newton's gravity fades with distance in precisely this way. Double the distance between two masses and their pull drops to a quarter, exactly like your balloons. Two completely different forces fading across empty space in the exact same way, letter for letter.
That's actually eerie. I came in expecting this charge business to be some alien new thing, nothing like the gravity we spent a whole course chewing on. And instead they thin out with distance in the identical shape. The only difference is gravity always pulls, and this one does both. Underneath, the distance law's a carbon copy.
A question worth keeping in your pocket. Why two such different forces agree that precisely? And I'll be straight, the deep why is a room we don't walk into for a long while, but feel the shape of the hint. Both forces weaken as though they're being spread thinner and thinner over something that grows as the square of the distance, as if each charge sends something out into the space around it, and that something has to cover more and more room the further out you go, so there's less of it to go round at any one spot. The square of the distance is the fingerprint of a thing spreading out into the space it lives in.
Spread thinner over something growing. Twice as far, 4 times the spread. 3 times, 9 times.
Hold that image. We'll need it again before long.
I'll hold it, but you've walked me all the way here without answering the thing that's nagged me since the balloons first swung apart, and I think it's about to get worse. We keep saying these charges push each other across the gap. Push? With what? There is nothing in the gap.
You're right to keep coming back, because we've been papering over that hole, and now the paper comes off. Let me say the comfortable version first, the one in your head right now, then why it kept the sharpest people awake at night. The comfortable version. Charge 1 reaches across the gap and pushes charge 2. It acts on it, over there, at a distance. Simple. Done.
Right, and I honestly don't see the problem. Charge 1 reaches over and shoves charge 2. That's what it looks like happens. What's wrong with it reaches across the gap and grabs?
Let me poke it. Reaches across. With what? Picture the two balloons with a hand's width of air between them, and now pump every scrap of that air out. Truly nothing left. A clean, total vacuum, emptier than deep space. Do the two balloons still shove each other apart? They do. The force never needed the air. So now charge 1 is meant to reach across genuinely empty space, no medium of any kind, a clean void, and lay a push on charge 2. Reach with what, if there's nothing there to reach through?
Empty space, and the push still lands. You just had me pump it empty with my own 2 hands. And yet, maybe it just does. Maybe reaching across empty space is simply a thing charge can do, and I don't need a rope strung across the middle to allow it. Why am I so sure something's got to be in the gap?
You're allowed to say that. Plenty of clever people said exactly that, shrugged and got on with the sums, because the sums work beautifully, whether or not you can stomach the picture. The law tells you how hard the push is, to marvelous precision, and never once whispers a word about how it gets across. You can compute forever and never touch the question. But it flinched the ones who looked hardest, and their flinch was right. 2 things gnaw at it reaches across nothing.
Name the 2 things. What gnaws?
First, How does charge 2 even know charge 1 is there? Nothing's carrying the news over. And second, does the push arrive the instant charge 1 moves, or does it take time to cross?
The second one hadn't even occurred to me, and now it'll bother me forever, thanks. If I jerk charge 1 a hand's width to the left, does charge 2 feel it the same instant? Right across the whole gap, no delay, however wide. That feels deeply wrong.
Why wrong? Say why your gut balks at it.
Because nothing else in the world happens everywhere at once. Drop a stone in a pond, and the far side finds out later. The splash has to travel. But this push is supposed to arrive instantly, across any distance, through nothing.
You've laid your finger right on the bruise. A push that crosses any gap in no time flat, with nothing in the middle to carry it, and the far charge somehow knowing to answer. That isn't a mechanism. It's a miracle with good manners. It reaches across, it arrives dead on time, and there's no machinery anywhere between the two doing the work. Every other push you know has something in the middle passing it along. The rope goes taut, fibre by fibre. The sound crosses the room, bumping air along the way. Take the middle away, and normally the push has no road to travel on. Here we've torn up the road, and the push still arrives. That's the scandal.
So my comfortable little picture isn't merely unproven, it's a bit monstrous once you stare at it. A reach with no arm. A message with no messenger. When you lay it out that way, I don't want it either, but I've got nothing to put in its place. Reaching is the only picture I own.
Here's a thing that ought to comfort you. You're in the best possible company. Newton himself, the very man who wrote the law of gravity, the engine of the whole last course, was deeply uneasy that his own gravity reached across empty space with nothing carrying it. He called the idea that one body acts on another far away, across a void, with no go-between, so great an absurdity that no one with a head for these matters could accept it.
Wait, the founder of the whole thing looked at his own law and said the reaching across nothing part was absurd. He predicted the planets with it, nailed the tides, and privately thought the mechanism underneath was nonsense he wouldn't sign.
He refused, flatly, to even guess at the mechanism. And he was right to feel the itch, and for a long time nobody could scratch it. The law worked. The picture underneath stayed monstrous, and people learned to live with the split. Which is a strange way for a science to live, with a law you'd trust your life to, and a story underneath it you can't quite believe. That crack sat there, open, for the better part of 2 centuries before anyone found the thing that closes it.
That's oddly reassuring. The hole in my story isn't me being slow. It was there from the very beginning, and the smartest man in the room refused to fill it too.
Which is exactly where this course begins. Because the answer, when it finally came, didn't come from making the reach faster or finding a hidden rope in the gap. It came from throwing out the reaching altogether. There is no reach. That's the whole turn.
Throwing it out entirely? But the reaching's all I've got. Take it away and I don't understand what's left standing. The balloons shove each other. If neither one reaches across, then what in the world is doing the shoving? Something has to be. I felt the sock cling to the towel with my own hands.
Here it is. The idea the whole course is built on. The reason it's even named what it's named. Charge 1 never reaches across anything. It never touches charge 2. Never sends anything over the gap. Never acts at a distance at all. Instead, charge 1 does something to the space around itself. It changes that space, near and far, every direction, all at once. It fills the space with a condition, and that changed state of the space is called the field. Notice the sleight the old picture pulled. It kept the space empty and made the force do something impossible across it. We're going to do the opposite. Let the force stay local and simple, and put the strangeness into the space, which is now not empty at all.
The field. That's the word right on the tin. Lines of force, a field. but slow all the way down because it changes the space around it is doing enormous work and I'm not picturing anything. The plain empty space around the balloon, what could it even mean to change it? Empty is the one thing it is.
Then let me turn it into a picture you can see. Forget charge for a moment. Think of a warm radiator in a cold room. Stand right next to it and you feel warmth. Step back and it's cooler. The far corner is cold. The radiator hasn't reached across and touched you. It's filled the whole room with a condition, a temperature at every single point. And that temperature is a real, definite thing at each spot. I could walk round the room with a thermometer and read you a value anywhere, over by the window, up by the ceiling, in the dead center where nobody's standing. The room is full of it, everywhere at once, not only where a body happens to be.
So the radiator doesn't reach out and warm me, it fills the room with warmth, and I feel whatever the room's doing right where I stand. I never actually feel the radiator itself, I feel the room against my skin.
You only ever feel the room where you stand. Now carry that to the balloon with one upgrade. The charged balloon fills the space around it with a condition too, but not a warmth, a plain single number at each point. At every point, it sets up a little push, a push with a strength and, unlike temperature, with a direction. Think of a tiny arrow planted at every single point in the space.
An arrow at every point. So it's like the warmth, but with a direction baked in. Not only how strong at each spot, but which way. The whole space gets carpeted with these little arrows, thick and strong up close, thinning out far off. A temperature was only a number at each spot. This is a number and a heading, a little signpost planted everywhere, each one telling a charge both how hard it'd be shoved and which way to go. That's a fuller kind of condition than warmth.
And that carpet of arrows filling all the space, that's the field. That's what changing the space actually means. A direction and a strength at every point, everywhere at once, set up by the charge sitting there.
Okay, the carpet I can hold, but how does the carpet fix my gap?
Watch. Charge 2, the second balloon, is sitting somewhere in that space. It doesn't feel charge 1 at all. It can't. Charge 1 is way over there, across the gap. What charge 2 feels is the field, the arrow, right where it's sitting. Local, nothing else.
Oh, wait. Oh, that's the whole thing, isn't it? There's no reaching because there's nothing left to reach for. Charge 1 doesn't send anything across the gap. It already filled the gap, filled all of space, with these arrows, before charge 2 even showed up. And charge 2 just reads the one arrow it's standing on. Nobody reaches across anything. The reach is gone. There was never a gap to cross.
The reach is gone. And feel how cleanly that dissolves both things gnawing at you. How does charge 2 know charge 1 is there? It doesn't, and it never needs to. It only consults the field at its own spot, the arrow under its own feet. It never has to know a thing about anything far away. Not how big charge 1 is, not how far off it sits, not whether it's even still there. All of that is already baked into the one local arrow. The faraway charge did its work ahead of time, shaping the space. Charge 2 answers only to the space right where it stands.
And the timing thing, the instant across any distance miracle, does that get fixed too?
Feel your way to it. If charge 2 only reads the arrow right where it sits, then when you jerk charge 1 to the left, what does charge 2 do?
It keeps reading its own local arrow, same as before. It doesn't feel a thing until the change in the field itself travels out from charge 1 and reaches where charge 2 is standing. The news has to walk across the field to get there.
You've run ahead to something we won't reach properly for a while. But yes, the change doesn't teleport. It spreads outward through the field, point to neighbor, at a definite finite speed, like a ripple crossing a pond, each patch of the field nudging the next. Charge 2 doesn't stir until the change reaches the spot where it sits. The gap gets crossed, but by the field taking its time, not by a charge reaching instantly. And that fixes Newton's scandal outright. There's a road after all, and the push travels it at a decent, lawful pace. No teleporting anywhere.
And that speed, I'm guessing, is another thing you're not going to tell me tonight.
It turns out to be a speed you'd recognize. That's all I'll say tonight.
You're doing the door in the dark thing again, I can hear it. Fine, I'll let it go. But all this makes me want the blunt question. This field, is it real? Or is it a bookkeeping trick? A tidy way of drawing the force so I don't think about the gap? Arrows carpeting empty space honestly sounds like something I made up to feel better.
That's the right question, and the whole course spends its length answering it. So tonight, I can only make a promise and show my reasons. The promise: the field is real, not a drawing, not a convenience, a real condition of the space, as real as the balloons. And I'll give you 3 hints of why, on credit, because none of them gets properly earned until much later.
3 hints on credit. I'll hold them loosely and not pretend they're proven. What makes you call an invisible carpet of arrows as real as a balloon I can hold in my 2 hands?
First, the field holds energy. Real energy out in the plane space between charges. You push 2 like charges together against their shove, and the effort you spent doesn't vanish. It's banked out there in the space itself, and let go, the space hands it straight back as motion. The energy was sitting in the field the whole time, in the gap, in nothing. Second, you can pluck it. Jiggle a charge, the field ripples, and that ripple races off on its own. And that ripple, it turns out, is light. Ordinary light.
Light is a ripple in this thing? You're just going to drop that and keep walking.
And the third is strangest. The field can outlive the charge that made it. The ripple keeps going after the charge has stopped. A thing that holds energy, that ripples, that can outlast its own source. That is not bookkeeping. That's a thing.
Okay, those are, I'll say it plainly, staggering if they're true. And you've very deliberately not proven a single one of the 3. Light is a ripple in this. The field keeps going after the charge is gone. Even as bare promises, they change what the field is to me. It stops sounding like a diagram I drew and starts sounding like the actual furniture of the world. Because a diagram doesn't carry energy, and a diagram doesn't outlast the thing it's a diagram of. If those 3 turn out true, then the field is more like an ocean than a drawing, a real medium, filling everything, that you can push on and store things in and set ringing.
The actual furniture of the world. Keep that phrase. Now let me make this carpet of arrows into something you can nearly see with your eyes, because one of the founders found a way to draw it we still use, and it's where the course gets its name. You've maybe seen the trick done with a magnet. Scatter iron filings on a card over it, and they snap into arcs, sketching the magnet's field for you.
The little slivers jumping into those looping curves, like the paper suddenly grew a grain. There's a version of that for a charged thing.
There's an electric cousin, yes. Scatter little bits around a charged rod, and they line up nose to tail, sketching its field the way the filings sketched the magnets. Each little sliver swings until it lies along the arrow at its own spot, and the whole scatter of them draws the pattern for you, unmistakable. Now, instead of peppering space with millions of separate arrows, the founder threaded them into continuous lines. Smooth lines that follow the arrows along, tip to tail, through the space from one to the next.
So instead of a fog of separate arrows, I draw smooth lines that thread through them, each flowing wherever the arrows point, like joining them into streams. Faraday's lines. The lines of force, the name of the whole course. So these are more than a tidy doodle.
Far more, but start with the plain picture. Around a single positive charge, sitting alone, the arrows all point outward. A positive charge shoves other positive charges away. Thread them into lines, and you get lines streaming straight out in every direction, like the spokes of a wheel or the spines off a sea urchin. Out, 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 everywhere you look.
And a negative charge is the mirror image, arrows pointing inward toward it because it pulls a positive charge in. So it's lines streaming inward, diving in from all directions. Out of the plus, into the minus.
The plus is a source the lines spray out of. The minus is a drain they pour down into. Hold on to those two words, source and drain. They run the rest of the course. And a line, once it leaves a source, doesn't just stop dead in the middle of empty space. It keeps going until it finds a drain to end on, or runs clean off to the far edge of everything. Lines begin on plus and end on minus. They don't fray out into nothing halfway across.
Source and drain. So the lines show me which way. Is that all they do? Direction?
They carry the strength too, and this is the clever part. Look where the lines crowd close together, packed tight, right up near the charge. That crowding means a strong field. Now look far out, where the same lines have spread wide apart, with space between them. That thinning means a weak field. So the same picture holds both facts at once. Which way each line points hands you the direction, and how densely the lines are packed hands you the strength. One drawing doing two jobs. That's why the founder's lines beat a fog of loose arrows.
So how tightly they're packed tells me how strong. Crammed, strong push. Spread thin, weak push. And, oh, that's my spread thinner over something growing from earlier come right back around. As I move out, the same fixed set of lines fans out over more room, so they thin, so the field weakens.
There's your earlier knot, untied in front of you. The fall-off isn't mysterious, it's just the lines spreading. Picture the same fixed set of lines pushing out through a ball of space around the charge. Go twice as far out, and that ball's surface isn't twice as big. It's 4 times as big, because a surface grows as the square of the distance. Same lines, 4 times the area to cover, so 1/4 the crowding at any one spot, and the crowding is the strength. 3 times as far, 9 times the surface, 1/9 the crowding. That's exactly the inverse square fall-off. Not a rule dropped on you from above, but the plain geometry of the same lines fanning out over a growing ball. A clue we pick up next time.
I'll hold you to that. Now, you set these lines up so carefully. There's got to be a rule they follow. What's the one thing these streaming lines are flatly not allowed to do?
2 lines can never cross, never once. There's no point anywhere in space where 2 field lines pass through each other, and there's a clean reason. Think what a crossing would mean. At the crossing, one line says the push points this way, and the other says it points that way. But a single point can only hold one arrow. A charge sitting exactly there has to be shoved in one definite direction. It can't be pushed 2 ways at once. It hasn't got 2 backs to be shoved in. So a crossing would be the field trying to tell one spot 2 contradictory things, and the field never does that. Wherever 2 influences meet, remember, they've already added into one arrow, long before you draw the line.
So the room around this balloon, the plain empty air I'd have sworn on my life was nothing, is actually threaded through everywhere, at every point with these lines, each carrying its one clear arrow, no point ever confused which way to shove. The room's been full this whole time and nobody told me. I've walked through rooms my entire life certain they were empty.
Full this whole time, at every point, each with its one unconfused arrow. And with more than one charge, the lines get richer, but the rule holds. Put a positive and a negative near each other, and the lines swing out of the plus and curve gracefully around to dive into the minus, arcing over, source to drain.
And 2 positives near each other?
Their lines shove apart, each refusing the other's territory. A bare no-man's land opening between them, where the 2 pushes fight to a standstill.
So with 2 charges, I don't get 2 separate carpets stacked up. I get one combined pattern, the lines rewoven into a new thing. Which raises the obvious question. At some particular point, if both charges have a say, which one wins?
Neither wins, they add. At that point, charge 1 tries to shove a little test charge one way with some strength. Charge 2 tries to shove it another way with its own strength. You take those two little arrows and add them, tip to tail, into a single combined arrow, the way you'd add two shoves landing on the same object. That combined arrow is the real field there, and it's a proper arrow addition, mind, not just adding up sizes. Two pushes of the same strength pointing opposite ways cancel to nothing, while two pointing the same way stack to double. Direction is half of what you're adding.
So every charge gets a vote, and the votes add up as arrows, point by point. A whole balloon's worth, billions of grains, fills the room with one grand combined field, every point holding the sum of all their pushes. However many charges wrote it, the room ends with one clear answer everywhere. And a charge dropped in anywhere doesn't have to poll all those billions one by one. It just takes the single arrow already waiting where it lands. All the adding was done in advance by the space, before anybody arrived to feel it.
One clear answer at every point, no matter how many did the writing. Now I want to sharpen this from a lovely picture into something you could put a size on, because I still owe you what the arrow at a point actually is. The strength of the field right at some spot. How would you even measure it?
I'd want to measure the push. Put a charge at that spot and see how hard it gets shoved. That's the only handle I've got. Drop something in, watch how hard the space shoves it. So the field's strength is how hard my little charge gets pushed there, isn't it?
Very nearly. But there's a wrinkle you'll spot the second I point at it. The size of that shove depends on two things, not one. How strong the field is and how much charge you dropped in. A bigger test charge feels a bigger shove in the very same field. It's like judging how steep a hill is by how hard it tugs you downhill. A heavier person gets tugged harder on the very same slope. The tug tangles the steepness of the hill together with your own weight, and you want the steepness alone.
So a heavier friend on the same slope swears the hill's steeper. The hill hasn't budged, he's just got more of himself to be tugged. Same trap here then. The raw shove can't be the field. Double my test charge, and the shove doubles while the field sits there unchanged. So, with the raw push, I'd be measuring the room tangled up with how big a probe I brought.
That's the trap exactly. Two people with two different sized probes would read two different pushes at the same spot and disagree about a field that's really one fixed thing. So you've contaminated the measurement with the size of your own ruler, and you need your ruler back out of the answer.
So divide it out. Take the push and divide by how big my probe was.
Exactly. Divide it out. Take the push your test charge feels and divide by how much charge it carries. Push per unit of charge. Now the probe cancels clean out. A probe twice as big feels twice the push, but you divide by twice the charge and land right back on the very same field.
So the field is the push per unit of charge, the shove a probe would feel, divided by the size of the probe. So the probe drops out, and I'm left with something belonging to the point itself. Which means it's crucial I do not call the field a force. It isn't a force. It's a force per charge, a force waiting to happen, per unit of whatever I set down there.
The actual force only shows up once you place a real charge in it. The field is the standing offer of a push. Keep "do not call it a force" nailed up where you can't miss it. Force per charge, never force itself. And its direction has a fixed convention. It points the way a positive charge would be shoved. Drop a positive test charge in, it goes with the arrow. Drop a negative one in, it goes against it, backwards up the arrow. The field points one way, and which way a given charge actually moves depends on its sign.
The standing offer. And a standing offer is there whether or not anyone walks up and takes it.
That's the crack that opens your earlier question. Is it real or bookkeeping? Because look what standing offer implies. The field at that spot is sitting there ready, full strength, pointing its way, even with no test charge anywhere near to feel it.
So the push per charge is defined even where there's no charge sitting to be pushed. The spot's loaded and waiting, arrow drawn, with nothing standing on it. The push doesn't need a victim to exist, it just needs the space.
The test charge was only ever your way to read the field, like dipping a thermometer to read a temperature that was already there before it arrived and stays after you pull it out. And a subtlety I've leaned on. We imagine that test charge vanishingly small, on purpose.
Small why? What goes wrong if it's big?
A big test charge would shove the source charges around and spoil the very field it's trying to read. So we picture it feather light, reading the room without leaning on it and changing the reading.
So the test charge is a measuring stick, I imagine, as light as I want, precisely so it reads the field without disturbing it. But the field it reads was already sitting there, and that's the whole case for it being real, isn't it? The map exists before any traveller walks onto it. The room's painted with these arrows, whether or not I ever drop a charge in to check.
The map exists before the traveller. That's the sentence to carry out the door. If the field were only the force on a test charge, it would blink out the moment no charge was around and blink back the instant one arrived. But it doesn't blink. Remember the third hint. Jiggle the source, and the ripple travels off and keeps going even after the source is long gone. Something has to be out there carrying that ripple through the empty space with no charge anywhere in it to be the ripple. It's there at every point, loaded, directional, holding its energy, ready to ripple. A real condition of the space, waiting, whether or not anything's ever there to feel it.
The space itself is doing the pushing.
The space itself is doing the pushing, a middleman you'll never see, standing patiently in every gap there is. You walked in holding one picture, and you're walking out holding its opposite. And it doesn't stop at the balloons either. Every force we meet for the rest of this course works this same way. Never a reach across a gap, always a field in the middle, filled by one thing and felt by another. Even gravity, in the end, gets retold this way. A mass fills the space around it with a field, and the far mass feels only the field where it sits, and Newton's old absurdity quietly dissolves. But that's a story for another course. Tonight it's charge, and the field it pours into the room.
Charge fills the space carries the push, the next charge feels the space. Learn to think in fields, and I've got the grammar of nearly everything still to come.
The grammar of nearly everything. And now that you know the field is real, we're ready to actually use it.
So where do we actually go from here? We've got this field, this carpet of arrows, these lines out of the pluses and into the minuses. Feels like a thing I can look at but not yet do anything with. What's the first real tool it hands me?
The first tool is to count. Cast your mind back to the lines streaming out of a lone positive charge. Spokes flying off everywhere, the source spraying them out. Here's the thought for next time. Wrap a closed surface right around that charge. Any bag you like, a neat sphere, a lumpy potato, doesn't matter. A complete skin sealing the charge inside.
A bag around the charge, any shape, and then?
Count the lines that punch through that skin on their way out. Just tally them. How many lines pierce the bag? And from the careful way I'm setting this up, you can tell the count doesn't come out random. It's telling you something solid about the charge you've trapped inside.
Oh, and I think I see why it's not random. Every line that leaves the charge has got to cross the bag somewhere, no matter how I draw it. A line can't escape without piercing the skin at least once. So a tight sphere and a giant lumpy sack both catch every line exactly once, and both come up with the same tally.
The bag is your free choice. The charge sealed inside is the fixed fact. Every line comes from the charge, so the number punching out counts up exactly how much charge is inside. And it doesn't care what shape you crumple the bag into. A tight sphere and a huge crumpled sack give the very same count. And if you seal up a patch of empty space with no charge in it at all, Every line that wanders in one side of the bag walks straight back out the other. Nothing starts or stops inside, so the count comes to nothing. The tally sees only what's genuinely trapped within.
So counting the lines through any surface measures the charge within, regardless of the shape.
And when you sharpen that simple picture into a precise, unbreakable statement, it becomes one of the great laws of the whole subject. A law that lets you find the field around all sorts of shapes without ever grinding through the separate pushes, one weary charge at a time. You pick a clever surface, you count what pierces it, and the field falls straight out, almost for free. That counting, made exact, is where we pick up next time, and the counting turns into a law that carries us a long, long way.
So next time we learn to count the field, and the counting hardens into a law. I like that as a door. Before we step through, let me gather the whole thing into a sentence or two I can carry home, because an enormous amount moved in my head tonight.
Gather it up then. The last word at the door is yours, like always. Hand me the shape of it, and I'll tell you whether you caught it whole.
Here's the shape. I walked in this morning with a crackle off a sweater and a hole in the middle of every push. Two things shoving each other across empty space with nothing in between, and no idea in the world how. And I was ready to fill that hole with a reach. Charge 1 throws an arm across the gap and grabs charge 2. But the reach was a monster. No arm, no messenger, instant across any distance, straight through nothing. And it troubled even Newton about his own gravity. And it should have troubled me. So we threw the reach out. Nothing reaches. Instead, a charge fills all the space around it with a field. A real invisible condition of the space, an arrow of push at every single point, out of the pluses and into the minuses, thinning as it spreads. And every other charge just feels the one arrow it's standing on. Local, immediate, no gap to cross, ever. The field is the middleman that was hiding in every gap the whole time. It holds energy, and it's ready to ripple, and it's the true main character of everything still to come. So the next time something pushes something across a scrap of empty space, I'm not going to ask how it reaches across. I'm going to ask what the space between them is quietly doing, because the space, it turns out, was never empty, and it was never once idle. It's been doing the pushing all along. That's the one I'm keeping. See you next time when we learn to count it.